Hi guys, I hope we are live. Can one of you quickly confirm? I am opening my chat over here and I would like to know from you guys also. Can you guys see me? Is the screen very clear? Are you able to see the question on the left side as well as the coding area on the right side, so that when we start, finally there is no problem in the connection and you can see me properly, you can hear me properly, and you can see the code also. Hi, so I can already see comments. So, hi Manu, can you please confirm that you're able to see everything properly? Although I'm able to see over here that you are, right? So, this is the question that we'll be doing today. Add all greater values to every node in a BST. This is a very good question. It is important for BST as well as for recursion. Your recursion concepts will be much more clearer once we do this question. Okay, so let's look at the example. So this is the BST given to us. We have to modify it so that all the greater values in the given BST are added to every node. Okay, so in a BST, all the nodes on the left side are smaller, all the nodes on the right side are bigger. Okay, it is true for every single node. So here let us see how our tree is going to be modified, how we have to modify it, and let's see that how we can apply the concepts of recursion, because it can be very tricky. Okay, so let's see the example. If this is the question given to us, the modified tree looks like this. So what are we exactly doing? See here, 80 is the largest element. There is no element greater than 80. So the node is going to be remaining same. But when we look at the node 70, okay, so what are the nodes that are greater than 70? It is just 80, right? So in this node, we add 80 to it. So it is basically 70 plus 80, it becomes 150. Now, when we look at 60, what are the nodes that are bigger than 60? It is 70 and 80. So we are going to add 70 and 80 to 60. So how much is that? It is basically 150 plus 60. That becomes 210. What are the nodes that are greater than 50? It is 60, 70 and 80. We add all of those values and we come to 260. So similarly, we go ahead with that. What are the nodes that are greater than 30? It is 40, 50, 60, 70, 80. So you add all of them to be 330. So for 20, you will be adding basically all the nodes other than 20 itself, and you will come to 350. So this is how you are actually modifying your BST. Over here also, what are the nodes that are greater than 1? All the other nodes basically. So you add 2, 4, 5, 7 and you will get 19. So that will be a new node. Okay. So here we can see that the greater values are always going to be the rightmost values. So we have to write code such that when we see the rightmost element, we know that we don't have to edit it, and we just keep calculating the sum from the rightmost element, from the largest element, and then we keep adding to the rest of the nodes. Okay, I'm looking at the chat, guys, so if you have literally any doubt, feel free to ask me. I am reading the chat over here, and that is the point of teaching live. Feel free to ask me any questions, even if you're a beginner and it is harder for you to understand. It's fine, you should be able to understand because you are here studying with me. It is okay if you don't have any background, you should still be able to understand. Okay, so let's get started. Here, first thing that you have to notice is that, okay, we'll obviously need to use recursion because we need to keep calculating the sum and pass it over, and we can divide this problem into smaller subproblems as well. But here we can't use this function itself as a recursive function because we will be dealing with sum as well. Okay, so we'll be coming up with a separate helper function. So right now, let me just start with sum. So this is the initial sum that I have, and what am I going to do? I'm going to make another function which I'm just calling helper. You can call it modify util or whatever you like. And what else do I need to pass? I need to pass root and sum to it. So we have to write this recursive function, and after this what is going to happen is that I would have modified my entire tree and I will just return root from here. Now another thing that we have to ask ourselves when we write a recursive function is, do I need to have a return value over here or not? Some people might return root from here and then go with it. Actually, I am not doing this. Why am I not doing this? Because in my helper, I'm going to be passing the pointer to the root. Okay, and I'm going to edit it over there itself. And suppose I was doing insertion or deletion and I had to change the left and the right values, then it makes sense that, okay, I have to pass it in the return statement. But here I'm not doing that. I am not attaching or detaching any nodes. I am just modifying the values present in the nodes. So I don't need any return value over here. So that is, you should think of all of these cases when you start writing code, that, okay, do I really need to, return something? How am I attaching, detaching? When to return, when not to return, when to add a helper function, when can I use the same function as a recursive function or not? So ask yourself these questions and ask me also in the chat Okay. Uh, I am writing the code on the screen, guys, so don't worry about that. Okay, you are not able to see the code. Okay, give me 1 second. Give me 1 second. I can see that you are not able to see the code, so I'm just trying to figure it out. Are you able to see the code now if I'm typing here? Okay, I just need to confirm that you're able to see the code, and then we will get back to start writing the code. I guess I was just sharing one particular tab and I was writing on another tab. So just confirm whether you're able to see or not. And then so there's a delay of 2 minutes actually, and that is why it happens that I'll be able to see only after 2 minutes only. Okay, not able to see. Give me a second, guys. I am so sorry about this. Okay. Are you able to see now? Hopefully, yes. Just when I thought that okay, we are finally doing a live where there is no technical issues and I'll be able to just teach peacefully, obviously this happens. From tomorrow we are going to make sure that I can use the iPad, also make more diagrams and give a real live experience. And I wanted to try this out so that once we get comfortable with live sessions, I can answer all your doubts also, and I guess it will be much easier for you also. I have set it up. I'm waiting for you to confirm on the chat. Again, there's a 2 minutes delay, so I'm waiting for it, but should work properly now, I'm guessing. You're able to see right now when I'm entering the code. Yeah, great. I just need a quick confirmation. I guess I should get a confirmation now. Yeah, guys. Great, awesome. I am so sorry for the delay. Okay, we're going to start writing the code again. So here we have the root. Okay, as we were discussing, here we can't use this itself as the helper function or the recursive function. Why is that? Because we need a sum that we're dealing with, right? So what am I going to do? I'm going to make another variable sum over here, and I'm going to write a new helper function. Okay, and I'm going to pass root and sum to it. Got it? So this is the function that we have to write. This will be our recursive function. Again, I was talking about that, do we need a return value or not? Here we do not need a return value because we are not attaching or detaching any roots. We are just modifying the present roots that we have. So we don't need to assign that, okay, node ka left is this or node ka right is this. So I am not adding any return value over here. If you have any doubt about that, just notice a bit more about insertion and deletion in BST more. Just try writing the code again and you will understand that what was the problem that we were facing when there were no return values. Okay, here we do not need any return values. So now what am I going to do? I'm going to write the helper function, and here I am passing the root value. Guys, I have my eyes on the chat, so if you have any doubt at all, just feel free to ask me. Okay, I've written the function like this. Now I need you to notice the mistake that I have done and tell me in the chat that okay, that you have done this particular mistake. The mistake over here, I'm telling myself before I can see in the chat because there's a 2 minutes delay. I am going to pass it by reference. Why am I passing it by reference? Because I need the sum value to change as I traverse through the nodes, right? If I don't pass it by reference, I'm going to create copies all the time and the value is not going to get reflected. So that is why I need to pass it by reference so that I know that okay, the value that I'm sending, when I change it, it is getting reflected in my recursive calls also. Basically, when I backtrack from my recursion, the value is changed. Okay. Here I need to go to the rightmost value first. So what am I going to do? I am going to the right value. If it is there, I'm going to keep traversing to the rightmost value. Okay. So here I'm going to keep calling the function, and first I will make sure that I am at the rightmost node. So I'm going to the root ka right and I'm calling the sum. Till here, do you have any doubt at all? Okay, I'm checking the chat. I'm okay. So someone's asking, what do you mean by reference? Reference means that when I am passing the this value, a copy is not created all the time. So basically, whatever changes I'm making to this sum is going to get reflected over here also. So I'm not creating a copy of the variable again and again. I am passing it by reference. So the change in the variable is going to get reflected in the function call also. So here I am making sure that I traverse to the rightmost node. So I call first for 50, then I call for 70, then I call for 80. So now I am at the rightmost node. Now what do I need to do? Whatever sum I would have passed, I need to add it to my root. Okay. So let me give you an example. Let us see from examples. So suppose I was at the node 70. Okay. So I have already traversed 80 and I am out, because see, this I would have already done. So whenever you are at a particular node, so suppose I'm at 50, I have already traversed through these particular nodes. So my sum value should technically be storing the sum of these values. So I'm going to add the sum to this root ka data. Okay, we're going to dry run it, and if it is not clear right now, don't worry, it is going to be clear. Now in the sum, for the next iteration, what am I going to do? I am going to assign it to this new data. I am not adding, I'm assigning. Why am I doing this? I need you to tell me in the chat. And after I have traversed to the right one, I have dealt with the present root, I'm going to deal with the left one. We are going to dry run, guys. Don't worry if it is not clear, just give it some time. Okay. So here I am calling root ka left and I'm passing sum. Okay. Now let's discuss this in detail. Here I am making sure that I am dealing with the rightmost BST. Then I am making some changes to the present root that I am dealing with. And then I am dealing with the left subtree. Okay. So why are we doing this? And why first right subtree, then why present root, and then why left one? See here, what we do is, we have to reuse the sum values from the right subtree in the left subtree, right? Because we have to keep adding the sum. So when I'm at 50 and I've already gone through the right subtree, my sum value already stores the sum of 70, 60, 80. So I add it to the root data. So now I already have the root data as 260. I have to pass it over here. That okay, now I will pass it to 30 to use this, right? So in every subtree, I am first going to the rightmost, basically the largest node, and then the root itself, and then the leftmost node. So let me just quickly compile this and see whether this works or not. And I'm waiting for your questions so that it is clear. I want to clear all your doubts. So if you have any questions at all, I want you to come and tell me so that I can clear it right away. Don't wait. Don't be scared of asking questions. Feel completely free. Let me just compile it again. There's some issue. Okay, if you have any doubts, guys, feel free to ask me. I'm here to clear your doubts. If you're shy, you won't be able to understand, right? So if you're able to understand this, you will be able to understand recursion properly. So you have to ask questions. You have to think of why we are dealing with the right subtree first. Why are we dealing with the left subtree first? Like that. Okay, there's some issue with... Give me 1 second. Let me just quickly see my submission order so this works. Let us compile this and see. Okay, I'm reading the comments, guys, so don't feel shy. Ask me all the doubts. So the compilation is successful. Let's submit. Also think of the time and the space complexity yourself before we discuss it. So we have submitted and it worked. So here the time complexity is order of n. Why is it order of n? N is the number of nodes that are there in the tree. Basically, we are visiting all the nodes once. Okay, so we are going through all the nodes once. We are first visiting the rightmost node, then the root, then the leftmost node. Like this, we are going to all the nodes one time. So that is the space complexity. What is the auxiliary space? So here we are using recursion. At one particular time, we will be down one branch, right? And what is the maximum length of the branch? It is the height of the BST. So that is the auxiliary space, basically the space that we are using for recursion. That is why. Okay. So Ritik is saying global variable sum equal to 0, then using the same given function. That is true. So if instead of this, so I usually, that is not my coding style, so I don't do that. Otherwise what you could have done is you could have made a global variable and you wouldn't have to write another helper function, because there is a global variable over here. You could have just, use the sum, and that, because it's a global variable, you can just, keep passing the values and you won't have to like make it a reference and do that. But because when you start coding in companies, what you'll have to do is not like, you won't be able to create global functions like this. So in a lot of interviews, your interviews won't appreciate global variables so much, but you can definitely say it that okay, I won't need a separate recursive function if I have a global variable. It does make sense. Okay, so I guess we are done for the day. We have done today's question. I will be doing live questions like this every day. If you want me to pick up any particular question, you can actually let me know and I will pick up that particular question itself. So I need you to come and tell me that, okay, what is working out for you, what is not working out for you, and I want to pick up the questions that you are facing problems with. I'm here to help you out, but I hope you will show up tomorrow as well. See you tomorrow at 5 p.m.